All right, let's look at the last section of chapter 12. We have touched this topic earlier, so we will just review what we have done. So in this section, we discuss systematically the quadric surfaces. Okay. In the textbook, we actually mentioned also in class that for the degree 2 polynomials, after some so-called rotation, we can actually reduce all degree 2 polynomials to these two forms. Now, of course, it is possible if you look at the first equation over here, you have all x and y and z, they appear in the square form. It's symmetric x, y, z. But if you look at the second one over here, z, the square sign has dropped. So over here, there's only one z. And more generally, we can have something like this. For example, ax plus by squared plus cz squared plus d equal to 0. Then, if you have something like this, it also belongs to category 2. It's just now your x is the z variable, right? So what it means is that the surface is simply rotated 90 degrees, and we get this one. So just to be careful, the difference between 1 and 2 is that one variable is now first order, other two are actually still second order. Now, there are other cases, but these are the typical ones. And for other cases, we can also use the same method over here we're going to describe to somehow visualize the surface. So the method over here is more important than the actual surfaces we are going to get. Now, the method we're going to describe is called the cross-section method, or here, the trace method. And it depends on still that those lower dimensional curves. And if we just have two variables in the equation, then we have mainly three types of, we say these are quadratic curves or conic sections. The first kind is when you have both x, y, they carry positive coefficients. Now you can always divide both sides by one of them. So it becomes x squared plus by squared is equal to d squared. And that's going to be an ellipse. And when we have parabolas, and that's when we have x equal to some y squared or y is equal to x some squared, right? And these parabolas will open up or down, left or right, depending on the signs of their coefficients. And also, if you have different signs in front of x squared and y squared, then we're going to have hyperbolas. Another form of hyperbola, that's before we rotate it, is x times y is equal to c. Hyperbolas, they have asymptotes. Parabolas, ellipses, they don't have asymptotes. Okay. All right. Now let's look at the examples we have over here. This example over here, we only have z to the power 1, and on the right-hand side, we have x squared plus y squared, and both coefficients are positive. So we know we're going to have ellipses. But we have three kinds of cross sections, and we're going to look at them in different cases. If we let z to be c, that means we move the xy plane up and down because z is a constant. then we are going to have curves like that. And we know these are ellipses because both coefficients are positive. But see over here, c must be greater than 3. Otherwise, we don't have solution. We have nothing. So you will see that the surface described by this equation is going to be above the xy plane. And the lowest point it can reach is 3. When z is equal to 3, then we have just a point. Okay, and these choices are also called contours. That's something we also mentioned because they are the cross sections with planes parallel to the xy plane. And for the next two cases, we are looking at cross sections with respect to either yz planes or xy planes, planes parallel to xy, to yz or xz, these coordinate planes. And we can see these are just parabolas. Depending on the value of c, we have different sizes of the parabola. Now let's try to make a summary and try to see if we can actually sketch the surface. We can use either one of these choices over here to graph it. If we look at the first one, then this is something what we have. So we have y and x over here. And z must be bigger than or equal to 3. Let's say this is going to be 3. If z is equal to 3, we only have a point. That's xy is equal to 0. And when z is bigger than 3, then we have ellipses. You can see which direction is longer. Actually, it's the y direction is longer, so you have something like this. Okay. And when z increases, you see the size actually gets bigger and bigger. Okay, this is something like we have. Okay. Right. And it continues. So this is the one we can get from 1 by using traces obtained from cutting the surface with planes parallel to the xy plane. Okay. And this is number 1. Number 2, we can also use planes parallel to yz plane. That means we move back and forth, right? And then we will see when we move back or forth, we are going to get we're going to have parabolas, and it's z equal to something. Z is equal to y squared and plus 4c squared plus 3. So we have something like this. First, we can try to draw the one when x is 0. That means in the yz plane. That's actually also the lowest one. When that's over here, we have y squared plus 3. Okay. And then when you move c, it's not very easy to see over here because when you move to the front, the parabola actually goes up and up like that. And if you move to the back, and it's similar. So it's pretty difficult to see what you're having over here. But if you look to the left, and the things we are getting over here is something like this. Okay. So these are the traces when you use x is equal to c to cut the surface. And number 3, that's very similar. But this time, we are looking at the plane parallel to the xz plane. XZ plane. You can also try to graph the one in the xz plane first. And this is again 3 over here. When y is 0, c is 0, we have 4x squared plus 3. So you have something like this. Oh no, we should remember that everything is above 3. Okay, so what we have over here is something like this, right? And then when you move y, this is c, back and forth, then we get also these curves over here. Okay. And you can see, for a surface, sometimes it depends. One set of traces is easier for you to draw and to visualize the surface. Obviously, in this case, it's the first one when we are using the contours. Okay. All right, let's pause over here, and then in the next video, we're going to do the second one.